Welcome to the Math 1700 video series. In each of the videos about the lessons, we're going to go through the workbook just like you would in a regular class, only you can watch the video anytime you want, or as many times as you want. So we're going to start with topic 1, Algebra 1, and we'll start with real numbers and their properties. And first, 1.1 is numbers. We're going to talk mainly about the real number system in this course, and the real number system is a classification system of numbers. The system is made up of sets of numbers, the natural numbers, whole numbers, integers, rational, and irrational numbers. Each of them is a different group of numbers, and you definitely need to know which numbers belong to which groups, or which numbers belong to which sets. The natural numbers are kind of the starting point of numbers, or the counting numbers. And these are the numbers 1, 2, 3, 4, 5, and this dot 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 just means continuing like that. So 6, 7, 8, 9, 10, as far as we can go. And normally we represent those with a capital N. Sometimes you'll see with 2 lines on the left. So that's the natural numbers. The whole numbers are actually the same set of numbers, the natural numbers, except now we have to include 0. It's a bigger set. It has all these numbers plus 1 extra. The whole numbers are generally represented with a capital W. The next set of numbers is integers. And what we do now is we take all the whole numbers, including 0, but now we have to include the negative and the positive version. So we have 0, plus and minus 1, plus and minus 2, plus and minus 3, etc., etc. So those are typically represented with a capital Z, because we save the I for a different set of numbers. And the Z sometimes has 2 bars in the middle there. So that's integers. The rational numbers sound a little confusing, but we can think about them a little easier than this. They're any number that can be written as a over b, where a and b are integers. Well, what does a over b look like? I think you'll all realize that a over b is a fraction. And really, we need one more piece of information here. This says any number can be written as a over b, where a and b are integers, but that's provided that b does not equal 0, because we wouldn't want the situation where we had a over 0, because that's undefined. You can't divide by 0. So let's make sure we add b not equal to 0 there in your notes. So this includes all the natural numbers, all the whole numbers, and all the integers. So let's just look at, for example, number 5. The number 5 is a natural number because it is a counting number. That also makes it a whole number. You see it's actually in both of our lists. It's an integer because it's the positive version of 5. It's also a rational number because we can write it as 5 over 1. So 5 belongs to all 4 of those sets of numbers. And rational numbers are typically Q as a symbol. As R we actually save for back up here the real number system. Also included with rational numbers are decimals that end or repeat. So repeating or terminating decimals. And the reason for that is because anything that can be written as a decimal, let's say 2.5, we can also write as a fraction. That would be 5 over 2. Or let's say 0.3 repeating, well, that's just 1 over 3. So any decimals that end or repeat can be written as fractions. That means they're rational numbers. The last part of the real number system then, the last subset we call it, of the real number system, are irrational numbers. And those are basically anything that doesn't fit any of our previous categories. So when all these number systems were created, we came up with numbers that didn't fit anywhere. Numbers like root 2 or pi. They're not fractions. They're not integers. They're not whole numbers. They're not natural numbers. They can be written as decimals, but they don't repeat. They don't end. So those all fit into a special category called irrational numbers. And that's Q with a line through it. Typically these numbers have roots There's special symbols like pi or e. Any root that is not exact, root 3, root 5, these are all irrational numbers. The main thing is decimals that do not end or repeat. We can use this nice Venn diagram here to represent how the sets of numbers work together. So all the numbers that we've talked about so far are real numbers. So that's the big outside part. Then inside the real numbers we have a large set of rational numbers and then a separate set of irrational numbers. There's no linking between these two. Within the rational numbers then we get integers and then whole numbers and then natural numbers. So let's look at our example we did a second ago with number 5. We know 5 is a natural number. Automatically, if it's a natural number, it also belongs here, and here, and here, and here, because it's contained within all of those. A number like root 7 would only belong to the irrational and real numbers. So we can use this diagram, if we can visualize it, to kind of see where the numbers belong in each place. There is two other sets of numbers: imaginary numbers, which are separate from real numbers, and complex numbers. Imaginary numbers are mostly covered in your next math course, 1101, but just so you know, these right now are the square root of negative numbers. So, for example, the square root of -7, or the square root of -2. If you do those on your calculator without changing the modes, you get an error, because for the real number system, the square root of negatives don't exist. Those are a special set of numbers outside of the real numbers called imaginary. And the set of numbers that then takes all of the real numbers and all of the imaginary numbers and puts them all together into one big group are called complex numbers. So that's any number that has a real part and an imaginary part. So it's all real and all imaginary numbers, including, let's just say, the number 2. 2 is a complex number because it has a real part, which is the 2, and it has an imaginary part. We don't ever write the imaginary part, but we could always say plus 0 times some imaginary part, and we usually write that with a special I that you see right here. Don't worry too much about this right now. Just know that a complex number at this point is any number at all. You'll see a lot more of this in the next course. So we're going to work through an example here where we're going to classify all the numbers according to which set they belong to. So this first example says classify each of the numbers by checking each that applies. So for example, the number -4. Well, the natural numbers we're counting, so it doesn't belong there. Whole numbers, we're counting plus 0, doesn't belong. Integer is where we first saw the negative, so it belongs to the negative numbers. And if it's an integer, it's automatically rational, because it can be written as a fraction, so it belongs there. Rational and irrational aren't connected at all. They're actually separate sets, so if it belongs in one, it can't belong in the other, so it's not irrational. It's not imaginary, because there's no I there. That's typically the hint that it's imaginary or a negative root. And every number is complex. So there's where that number belongs. So let's go overhead for the next few now. 0 is not natural. We added 0 for the whole numbers, which makes it an integer, rational, and all numbers are complex. 8 pi, well, this pi is a dead giveaway for us. Pi is irrational, so automatically it's irrational, which means it doesn't fit in any of the rational number or rational number sum sets. Irrational and complex. So -3/4 then, not a counting number, not 0 or a counting number. It's negative, so a lot of people do tick this one, but remember the integers are positive and negative whole numbers, not fractions, not decimals. The first time we saw fractions was rational. So it's rational, means it can't be irrational. There's no I, so it's not imaginary, and it's always complex. -√7, so the negative is before the root. That means it's irrational, because if you try √7 on your calculator, it's a non-repeating, non-terminating decimal. Imaginary would mean the negative was inside the root. It's not, it's outside, so it's not imaginary. and it is complex. Here we have the pi, dead giveaway, irrational, complex. Root 2, again, try it on a calculator, non-repeating, non-terminating, so irrational, complex. Yes, this is a fraction. So a lot of people make the mistake of choosing rational. But it's a fraction that has an irrational part. If any part, like this, or this, or this, is irrational, the whole number is irrational. The last two examples then, we have a negative under a square root, automatically imaginary, and again everything is complex. The reason I skip all these, if it's imaginary, well, these are all real numbers. If it's a real number, it can't be imaginary. If it's imaginary, well, it can't be a real number. So if you tick this one, none of these can apply. Same thing here. We have an I. Automatically, it's imaginary, and they're all complex. So that's the end of our first lesson on number sets. And don't forget, if you have any questions, make sure you ask your teacher, get more examples, do some practice,